Howdy there, Internet students. Mr. Hermanson again. Today we're going to learn exactly what a function is and how to identify them. Okay, a relation that pairs uh, in one set called a domain with numbers in another set called the range. Okay, so basically domain is the same as your input, your x values. The range is the same as your output. And we often use ordered pairs to show this. In this case, the domain is a set of x values, the range is a set of y values. Okay, so here's the definition. This is what we need to figure out. A function is a special type of relation in which each value in the domain, each input value, is paired with exactly one value in the range, one output value. So whenever you input into a function, you only get one answer out. Okay? So go ahead and fill in these blanks, see if you get them right. Oh, here you go. How'd you do? So the domain is what we're used to calling the input, or the x values the range. Y values output are all the same, and the function rule, which normally we've been calling like an equation with an x and a y in it. Okay, so here's one way we're going to tell if it's a function. We're going to use a mapping diagram. So I'm going to put all of my domain in one of these jars, and I'm going to put all of my range in the other jar. Now, of course, you have to remember what domain and range are. So domain are the x's, range are the y's. So my x's are -3, 0, 1, and 2. My y's are 1, 2, 1, and 4. So 1, 2, and 4. And then I'm going to just draw an arrow here to map this out, to connect these ordered pairs. So -3 goes to 1, 0 goes to 2, 1 goes to 1, and 2 goes to 4. Okay, now what you want to look at to tell if it's a function is, remember that each input value can only have one output value. And you will know that if you only have one arrow going from each domain value to a range value. So this is a function because there's only one answer. If I ask you what's the output when the input is 2, you would tell me one number, 4. If I ask you what is the output, the answer when the input is 1, you would tell me one answer, 1. If that's the case, then it's a function. If your mapping diagram turns out like this, it's still a function because I'm only getting one answer when I'm given an input. If I give you the input of 3, you tell me the answer is 7. As long as you're only telling me one answer, it's a function. Let me show you one where it's not a function when we're using a mapping diagram. Okay, notice how with this drawing there are 3 different answers you get when you have an input of 3. If that happens, it's not a function because you can only have one output for each input. So this one is not a function, but the other 2 examples I gave you were functions. All right, I'm going to let you try that. Go ahead and fill in the jars correctly and put in your arrows and see if you think this is a function. You should be thinking this is not a function, and the reason it's not is because of this number right here, the 5. It has 2 different range numbers associated with it, 2 outputs for 1 input. That is not a function. All right, go ahead and try another one, see if you get it right. So you should notice that the relation map each domain value to exactly one range value. The answer is no, there's one range value that has one domain value that has 2 range values. So this is not a function. All right, so another thing we can do to decide if a graph a relation shown by a graph as a function is something we call the vertical line test. Okay, so if a vertical line passes through more than one point on the graph, that means that for some domain value there's more than one range value. So the relation is not a function. So I'll show you a couple examples here. We're going to do these two separately. So we're going to graph the points in part A here. Go ahead and do that. I see you don't have a very good graph for that. So so here, I'll make one and you can just kind of sketch this. All right, so if I take this vertical line here and I pass it over this graph where these points are, so here's the input of 6, there's one output, 1. Here's an input of 5, there's one output, 1. Here's an input of 3, there's only one dot there. Here's an input of -2, there's only one dot there. Here's an input of -4, there's only one dot there. That means there's only one output for each of these inputs, which means this is a function. Okay, now to create this other function, part B here, what we're going to do is make a quick little table using these x values as our input. So I'll let you go ahead and do that, see if you get them right. Before you graph them, you might want to check with what I have just to make sure you're doing them right. But so we're going to do -4, -3, -2. And then we're going to use vertical line test. So go ahead and find those outputs. All right, so here's the points given by that rule, 2 times x squared. Remember, when you square negative, you get a positive, so that's why you might have gotten a different answer there. But anyway, so these are the points, and since it's an equation, we're going to go ahead and sketch the line that would be created by connecting those dots. All right, and then I'm going to, not a very good line there, and then I'm going to use my vertical line to test it. Now, if this vertical line hits the graph in more than one point anywhere along the way, then we would say it's not a function. But for any input, like say the input is 3, the output is just one number, and you can tell that because it's only hitting the graph in one spot. All right, so both those are examples of functions. All right, I'll let you try one. Go ahead and graph these, and then think about a vertical line, and if a vertical line hits more than one point at one time, then it's not a function. Okay, so can you draw a vertical line that intersects more than one point? The answer to that is no. I drew all the vertical lines where those inputs are. So is this a relation, a function? The answer is no. Whoops, I'm sorry. The answer is yes there. No and yes, it's a function because the vertical line doesn't hit more than one point. Okay, so let's do this last little exercise. Take a vertical line, or imagine a vertical line, and imagine if when you move that vertical line over each of these graphs, whether they may hit more than one point or not. Like I'll do the first one with you here. Notice that that there are places where this graph would hit this vertical line at more than one spot. So we're going to say no on this one. All right, you do the rest of them. All right, here's my answers. How do they agree with your answers at all? Now, on this one, this is the one where students miss the most. They think, well, it looks like it's hitting 2 places there. But remember how number line works? If there's an open circle, then that specific value where that open circle is not part of that set. So there's actually only one dot there because it's going through an open circle. So that is indeed a function. All right, the second part of this I'm going to do for tomorrow's lesson, but so you should have the information you need to go ahead and start the assignment. Message me if you are having any issues. Other than that, we'll talk to you soon.